So for this example, we have two temperatures, a hot temperature of the first piece of steel, which is 400 kelvins. We have a cold temperature of steel, which is 300 kelvins. And we have a thermal equilibrium temperature. And because the two pieces of steel are identical, then the amount of heat lost by the hot one to the cold one would be the amount of heat gained by the cold one. So we expect the thermal equilibrium temperature to be halfway in between, so 350. And now if we look at the change of entropy of the hot piece of steel, we saw in the last example that if we have an object that's heated from some temperature T initial to some temperature T final, that the change in entropy is given by this integral. And when we solved this integral, we found out that it's the mass times the specific heat over the natural log of the ratio of the temperatures T final over T initial. So the change of entropy for the hot piece of steel would be the mass of it, which is 4 kilograms. The specific heat of steel can be looked up as 450 joules per kilogram Kelvin times the natural log of T final is our thermal equilibrium temperature, and T initial for the hot was 400 kelvins. If we do this, we get a change in entropy of negative 240.357 joules per Kelvin. And let's do a similar calculation for the cold piece of steel. It's going for some temperature T initial to T final, mass, specific heat, change in temperature, the integral of that. Again, as we expect, will give us mass times specific heat times the natural log of T final over T initial, but now for the cold system. So this is again 4 kilograms. It's still 450 joules per kilogram Kelvin times the natural log of, again, 350 is the thermal equilibrium of the T final, and T initial cold was 300 kelvins. Do this and you get a positive 277.479 joules per Kelvin. So the total change of entropy then is going to be the sum of these two, the hot change of entropy plus the cold change of entropy, which is negative 240.357 joules per Kelvin plus 277.471 joules per Kelvin, which is a positive 37.114 joules per Kelvin.